looks like our fun little thunderstorms finally stopped over the weekend and has let us dry out a little bit. However, we did just have a customer come back into town after being gone for several weeks, so they missed all the fun. However, unfortunately, their heating and air conditioning system is not operating on one side of the house. After discussing it with it for a little while, it did turn out that a lot of their clocks, digital clocks, oven, microwave, that kind of thing, needed to be reset where the time was all off. So hey, we had a power outage or two kind of situation. And he did state that they do have 2 Bosch units on the home, and I think he said one was a Goodman. However, it is one of the Bosches that is acting up. That is an inverter drive system produced by Bosch. It's a fairly interesting little system, non-communicating inverter, where the outdoor unit is monitoring its own pressures and temperatures, outdoor ambient coil temperature pressures, and deciding how to ramp up or ramp down based on that. So pretty neat little system, kind of halfway between communicating inverter and two-stage standard heat pump system. So we'll stop by and take a look. Hopefully it's nothing major. However, a lot of these inverter drive systems are very sensitive to power surges, but also power brownouts, and that tends to be where I see more issues with them, just because typically you'll have a surge protector installed. But we'll take a look and see what we find. Alright, what we see immediately is an H8 error right here. And I believe on these Bosch units, if I recall, that is a pressure transducer fault. So how you actually troubleshoot pressure transducers, and if you can imagine, these units are doing much the same that our gauges do. It's actually watching the ambient outdoor temperature, the coil temperature, our temperatures on our lines, and the pressure transducers actually watching the refrigerant pressure. And as it's doing all that, it's using that information to decide how to modulate the compressor and fan mode on this guy to better accommodate for whatever particular load is going on. So to check the transducer here, I believe we're looking for C16, which is this little red, black, and white plug-in here. So we want to go over to DC mode, and if we look between, I believe it's red and black, if I remember, we should see somewhere between 4.5 and 5 volts DC, and we're seeing 4.9. So if we weren't seeing that, that would tell us we had a board issue. Since we are, that tells us we have an issue with possibly the transducer itself. So the way we check that is we go back between the white and black wires here, and you'll just see we're showing 0.03, which honestly, that would tell me that more than likely we're out of range. What this transducer is actually doing is, I believe it's a piezoelectric, or piezoresistive rather, little tension gauge essentially. So we've got a diaphragm pushing up against it, and as that little piezoelectric or resistive piece rather deforms, stretches, moves a little bit, it changes the resistance in it, and that will give us a pressure reading once you calculate how much voltage you get through it. And I believe, if I can find my phone here, I'll look this up real quick, because I'm fairly sure if we see anything that low, that is an indication that we have a bad transducer. So yes, according to our chart, 0.5 volts would show us that we were essentially at zero pressure. So we'll check our pressure, but honestly, anything below that 0.5 volts would tell us we have a problem with our transducer, because it should never be able to fall that low. And attach our manifold. hissed, so we definitely have more pressure than zero. Yes, sitting here static, we've got 224 pounds of pressure at PSIG. So being that we're seeing a reading between that black and white of 0.03, which is below the 0.05 of zero, yeah, we definitely have a bad transducer, so we'll order one and go about the process of replacing. The main problem we have with it is, as you notice, this is not a screw-on or flare, so we are unfortunately going to have to sweat out the original there, and to do that we'll have to evacuate this system. This guy down, it was holding just shy of 11.5 pounds, about 11 pounds 5 ounces. So pretty close to what the manufacturer specs said on it. So what we'll do with our new one is try to help dissipate that heat a little bit. So we'll take some of this thermal trap putty. Try to get a lot of good contact with this guy. We will pull off the pipe just because we are very close to our sensitive little switch here. We've got some nitrogen pressure on there and it seems to be holding. We'll just let that sit and see if any micro bubbles develop while we clean up some of our tools. Got our nitrogen purged, so we will go ahead and start the vacuum while we are getting through here, running a wire back through and taking some zip ties and trying to reattach all our nice little wires that were so nice and neat that we so callously disrupted. Plugging back into CN16. Vacuumed it down to about 473 microns. We'll let this guy sit for 15-20 minutes or so and just make sure it holds. And if so, we'll be ready to charge it back up. We've stopped ambiently pulling in refrigerant, about 240 pound static charge. So we'll go ahead and plug this guy in, let him boot up and start up, and we'll show you how to put it in charging mode to ensure we have a correct charge. So notice our compressor's not running yet, but our blower started, or our condenser fan started. We just heard it click. And what this guy's doing is essentially it's checking ambient outdoor temperature, coil temperature, has a call for cooling, and eventually once that compressor starts up, that 92 degrees where it's showing us our outdoor ambient will change over into essentially a run percentage. As we said, now we're actually operating the compressor. I don't know how it comes out on the camera, but it's going up 10, 19, 20% now, slowly creeping up. You can see correspondingly our pressures are changing, so our inverter is starting. And again, this guy is actually monitoring using that pressure transducer, ambient temperature controls, and coil temperature controls. And it's going to modulate itself around a little bit, but something you do have to remember with them is if you are low on refrigerant, which you know we are because we haven't completely charged the system, it will not allow it to ramp up all the way, so you never really see what you're running. So it's very possible to come across these, look at your gauges, check your subcooling, everything looks more or less right, and in reality it is not, because what's going on is this system, you can see it doing it right now, it's backing back off the inverter compressor in here to a point that it's not going to be below freezing any longer. So you may come out and see one that looks perfectly fine, and you might look over here and say, oh, well, we're only running 30%. Wonder what it does when we run a higher percentage. So the way you do that is these two little buttons up here. You see the one on the right says force. Just press that for a second or so and release, and you see that funny little symbol. It's kind of, again, I don't know if it comes out real well, but it's a straight line with a little dash over. And that puts it into forced charging mode, and naturally my manifold turned off. So now we'll let that run for a second. And once it starts picking up into charging mode, we'll see what it's actually doing when it's running 75% and higher. So now that we're running a little higher into charging mode, you see we have very low to close to zero subcooling, and just at about freezing. We are slowly ramping up to 75% speed on this guy into charging mode. And you do have to remember, when we're doing this, we're bypassing all the normal features of this guy, essentially, where normally it would be monitoring the pressures, temperatures, and adjusting this compressor to not allow itself to get down into this freezing range. So again, it's something to watch for when you ever run up upon these in the wild and look at it and say, well, refrigerant looks good, I'm done. It's just not cooling well, it's too hot, I guess. That's because you're probably only running 20 or 30%. But this particular case, we do have an expansion valve on the inside. So you have to remember, every time we add a little refrigerant, right now that expansion valve's equalizing with this pressure, taking our essential superheat measurement with a bulb on the line, and it's pressing down on a diaphragm against a spring, so opening that valve, letting as much through as possible. When we open up our line here to add a little refrigerant to it, what's happening now is we're increasing the pressure on this, which is dropping the temperature on our line. So that valve is going to want to start closing down because it says, whoa, wait a minute, something's way wrong. We got too much pressure, too low temperature. So it is kind of a seesaw procedure, because every time you add a little bit to it, it's going to take a second for it to readjust and figure itself back out. Alright, we're 8.5 subcooling, 40 degree vapor saturation point, 100 degree liquid saturation point. So this particular unit, it calls for about 10 degrees subcooling, plus or minus 3. So we're within that margin of error. We are running in basically forced high speed mode for charging, but we'll leave it this way for this particular cycle because they are about 90 degrees inside right now. So we'll just let it complete this cycle in high speed mode essentially. hopefully easy service call turned into something a little more entertaining. We pulled that cover off that Bosch unit, and our error code did give us the nice H8, which on those Boschers is on those Bosch units, they're telling us that we do have a pressure transducer issue. Do kind of be aware, and this is not just Bosch, but any fault code you read, take them more with a grain of salt. They're really more pointing you in the general direction. So in this particular case, I was checking between the black and the red, because on these particular units, you want to see about 4.5 to 5 volts DC there. If you do not see that, then you probably have an issue with your board itself and not a transducer issue. Then we saw that was okay, being 4.97, I think it was. So we moved along to the black and the white, which is telling us what the actual resistance or the voltage coming through the resistor in here is. So we were seeing, I think it was 0.033, which is below the 0 set point on that. I think 0 is 0.05 on that guy. So being that we had 220 pounds of static pressure, give or take, and had a 0.033, we know the transducer's got to be bad. Replacing them really isn't that bad. It's in of itself, other than the fact that these are braze-on, so we do have to evacuate all the refrigerant out of the unit. Do our little nitrogen purge, everything, sweat the old one off, and you see how much material or distance we have to work with to try to braze that in. You don't want to get that too hot. It's a sensitive little thing. So do either put some kind of heat trap material on there. I was using a putty in that particular example. They make it in gels. They make it in, it's almost like a grease or a paste, I see it at. It's like a, comes in a tube, almost like toothpaste. But anyway, if failing that, just get a damp rag and tie it around the thing. Just something to help you trap the heat and keep it out of this sensitive component. But got that all brazed in, and once we go into charging, you got to remember also, because of the way these units use that, they are not, the Bosches are not communicating. They don't have any idea what's going on inside the house, inside the structure, inside the air handler, what have you. It's just straight analog, basically. 24 volt turn on, 24 volt off, turn off. So it's modulating itself based on the pressure and temperatures it's seeing on the outside, using these transducers and thermistors for the coil and ambient temperatures. So what can happen, you can have an issue where you're actually low on refrigerant, but because of the way this thing modulates, it essentially says, hey, looks great, I got a 10-degree subcooling, everything's good, and you run away. I've seen that happen before, where a technician runs over and looks at the unit, gives it a pass, takes off. They call me the next day because it's not working, want a second opinion. I pull the cover off and the thing's only running at 20-25%. So yeah, it's working great at 25%, but once you start ramping up, it can't, and it won't ramp up because it's realizing that once it starts trying, its pressures and temperatures start slipping. So they literally try not to let themselves freeze. I've actually come across them before where the indoor unit's not even running and the outdoor unit looks almost right. You're sitting there scratching your head, well, this is weird, what's going on? And then go inside and think, blower's not running, okay. So that is something to watch out for, and when you're charging these guys, be aware of that, because we can add refrigerant to it and it'll look almost right, because now we've got an expansion valve operating and we have a compressor and a condenser fan that's modulating to try to hit optimum output. So you can actually have them look quite right when they're not. So you do have to put them in charging mode. On those, you just press that force button for just a second or two, and you'll see that weird little, it's like a little red kind of weird inverted or sideways T shape, and that's just telling you it's in force mode, and it will eventually ramp itself up to around 75%. That way you have a static set point to be able to actually monitor your subcooling and see what's actually happening. So we put it into force mode, let it go, got the charge corrected, and we just left it in that mode because it'll run that forced mode until the cooling cycle kicks out. Then the next cooling cycle, it'll just go back into regular mode. Being that it was in the 90s in the house, we just left it that way so it would be running maximally and get them cooler as quickly as possible. But it's time to run into Publix and grab a sandwich, so we'll catch you next time.